See here, this is the problem. In this, you have to find out the moment of inertia of the given section. Okay. So the centroidal axis you have to determine. Okay. So what initially, as soon as they're given, first to determine the moment of inertia, first you need to determine the centroid. Okay, centroid you determine. First you keep it in mind. First you have to determine the centroid. Okay, then for the finding the centroid, then you have first centroid you have to determine, then moment of inertia you have to determine. This two steps you have to do it. Okay. For the determining centroid, what you have to do is, first you see the section. Okay, so previously we have solved many problems on determine the centroid. So like this, so first you see the section. So as soon as you see the section, you divide it into two parts. Okay, you cut exactly here and you cut it exactly here. Okay, cut here and try to fold like this. Okay, try to fold like this. Okay, however it is there, you try to fold like this. When you start folding like this, so the section after folding that, this will lies exactly on this one, this part, whatever rectangle part is there, this one. Okay, that will lies on this. Okay, this part, whatever this is vertical rectangle, this is considered this is a horizontal rectangle, this falls on this. Okay, this falls on this. So exactly it doesn't looks prismatic. Okay, not prismatic in y direction. So next you cut the section at here and try to fold like this. Okay, so it will be exactly similar. Exactly, if you cut at 300 divided by 2, that is 150 here, exactly fold it here, that will be prismatic. So it is prismatic in x direction. Your folding will be taking in x direction. This is folding, it is in this direction it is taking place, means it is prismatic in x direction. If the folding is taking place in this direction, means it is prismatic in y direction. Okay, so now in the y direction it is not prismatic, so in the x direction it is prismatic. So you no need to determine y. X bar you no need to determine. Okay, x bar no need to determine. Okay, only y bar you have to determine. To determine y bar, use the formula sigma ay divided by sigma a. Okay, sigma a, you expand it, sigma ay and sigma a. So there is a three sections, section 1, section 2 and section 3. Just expand it. Ay is there, so you expand it. A1 y1, A2 y2, A3 y3. The same thing also here also, denominator a you have to expand. So three sections are there, a1, a2, a3. So this is the formula, you have to use it. Okay, so next after finding this, next what is your job is, so simply you find out the area a1 y1, a2 y2, a3 y3 and a1 a2 a3. So you observe in the formula, here a1 a2 a3 is there, here a1 a2 a3 is there. So what you do is, so first you determine a1 a2 a3. Okay, so after determining a1 a2 a3, then you determine y1 y2 y3. That's all. Okay, next y1 y2 y3, just to substitute the values in the equation. Okay, so area 1 is nothing but 300 into 10, and second one is the 300 into thickness is 10. Second area is a2 is 300 into 10. So because the rectangle area is length into breadth. Third one is 10 into 200. So write it 10 into 200. So what is this y1 y2 y3? So this is very important and little bit complicated. Be very very clear and crystal clear in this finding the y1 and y2 and y3. Okay. So I will teach you how to find this y1 y2 y3. Okay, see here, whatever the given section is there. Okay, so I divided section like this. So 300 is the length, 300, if 150 here, 150 here, and 100 here, 100 here. Okay, exactly I cut at the center. So you have to find out this centroid. So area 1 I teach you what is that, is 300 into 10. So it is 300 into 10. Another is, this is the thickness is 10, height is 300, it is given, you write it as it is. Okay, next is y3. Okay, y3 is, so that is, here the thickness is 10, the length is 200 into 10. Okay, so that's what you have to write it. Okay, clear? So after writing this, then what you have to do is, take the area whatever you written in the inside the bracket, so same thing you bring it downwards here. Okay, so whatever 10 into 300 you write it here. So individually whatever it is written, the same thing top whatever written, same thing you have to write it in bottom. A1, A2, A3 remains same. Okay, next is y1, y2, y3 you have to find it. That's all. Okay, so see here, I will show you that in the sheet. Okay, see here, individual section. Yes, I have there is a 3 section, you have to take it 3 section. Okay, so area 1, 2 and 3. Okay, so just what I made it is, just I made it separately. So if I bring this rectangle to here, it will lies above here. Okay, like this. Like this it will lies. Okay, if I bring second section, this one to here, means next third section whatever it is there, if I bring on top of it, you will get this section like this. Okay, that's very simple. So just I separated. Now y1 you have to determine. Y1, see here, the length here, the height is 10. Okay, length is 300. This is the first section, so no need to go for the length, you need to determine the height. Okay, so center of this section to the reference axis. So for all this 3 sections you have to make it common reference axis. Okay, this is a common reference axis. For this common reference axis, every individual center, okay, every wherever the center of whatever be the section, for individual section you take it individual section. So consider this is the height of 50 meter means. Okay, center will lies exactly at 25 meter. Okay, that is d by 2. Same way here also the height is 10, the center will lies at 5. Okay, so that's why y1 is 10 divided d divided by depth is 10, 10 divided by 2 is 5 mm. So that is y1. Next y2 you have to determine. Okay, so here considered the height is 300 mm. Okay, it is given in the question, it is given in the section. Okay, whatever the section is there, see here, this is the section. So in this section the height is 300, the center will lies exactly at 150. Okay, got it. But you need to determine from here to reference axis. So from here to here it is height is 150. So from here to here it is 100. Okay, how you got 150 here? How you got 150 from here to here? It is it's very simple. The height from here to here height is 300. So that's what I'm showing in the arrow. So that is 300 mm from here to here. The center will lies at exactly 300 divided by 2. That is 150. 150 at the top and 150 at the bottom. So you need to, this is the center, you got it. Okay, from the center to reference axis, what is the distance? So from here to here distance is 150, you know. But what is here from here to here? That is nothing but thickness. Okay, thickness it is 10. Okay, see here, the thickness is 10 mm. Okay, here nothing but here the center is here, from here to here. Okay, you know, from here to here that is 150, here to here it is 150. Okay, from here to here what? The thickness here to here it is what? That is 10 mm. That is given in the question only. Okay, so that's why the total will be 160. Okay, so that's why I have written here the first initially this thickness is 10, I have written here. Okay, so from here to here the total height is 300. 300 divided by 2 is 150. So 10 plus 150. Okay, that's what I written, 10 plus 150. So y2 will be, for this section will be 160. Next this section. Okay, see here, very clearly you have to see it. See here, from here to this bottom of this section is 310. 300 plus 10, so totally it is 310. I have written 310 here. Okay, next is the thickness, this is 10. So center lies exactly at 10 divided by, exactly lies at 10 divided by 2. So that is whatever that is 10 divided by 2 is 5. Okay, so that's what I have written. The from here to bottom here it is 310. I have written here 310. So from here to here it is 5. So that is 10 divided by 2. Okay, the total height is 10. the center will lies at here, it is 10 divided by 2. Okay, so that is 5 I have written here. Okay, totally from here to here the distance is 310 plus 5. Okay, so totally it will be 315 mm. Okay, so this is how you have to find out the y2, y1, y2 and y3. Okay, so whatever it is there, you substitute it. Okay, so y1, y2 and y3 have been determined now. See here, just I will show it here. Y1 is 5 now. See here, you have used y1 as 5. Okay, y1 here it is 5, you have used it. Okay, next y2 is 160. So here it is y2 is 160. Okay, next here it is y3, here it is 315. So you got 315. So like this you have to find out the y2, y1, y2, y3. Okay, no need to put any table and nothing. Okay, just take the individual area a1, a2, a3 and find out y1, y2 and y3. Okay, substitute it and find out the centroid. So what now you got it answer as y dash as 140.625. so what is this 140.625 is the centroid. Exactly, the centroid will lies at the from the reference axis. The centroid will lies exactly at 140.625 mm. You will get the centroid. Okay, so you know that in the x-axis, will lies at here. Okay, so in this line only you will get the centroid. But from here to here, what height you will get it? So that height you will be determined by using this. Okay, so in this from here to here it will go like this, and exactly at 140.625 you will get the centroid, that is y bar. Okay, so because see here this line how you got means, if you cut it 150, this is total length is 300 divided by 2 is 150. So if you cut exactly here and fold it here, so centroid will lies on this line. Okay, centroid will lies at this line, but in this line where it lies, so you start from here 0 1 2 3 mm like that. You started 1 2 3 10 20 30 40 50 60 like that. It will go exactly at 140.625 from the base. You will get the centroid. So if you pivot the pinpoint at here, consider this is the section, a wooden section. If you keep a pinpoint here at here, it will get balanced. This section will get balanced. So this is what the centroid section. Okay, so this is how you have to find it. Next, second job is, okay, so I will tell you next. First job is centroid determination is over. Second job is I value you have to determine. So how to determine that I value, I will tell you. See here, to the general formula to determine the moment of inertia is Ixx or Iyy, both are same. Ixx or Iyy is equal to moment of inertia to the centroid plus y into d square. Okay, you have to use this formula, moment of inertia in the x direction and moment of inertia for y direction. This is the formula which you have to determine for the both the direction. You have to find out the moment of inertia. So you take the general formula only. Okay, don't forget this. I is equal to I reference axis whatever. Okay, you write it as a. I is equal to IC plus area into y into this is area. Okay, area into d square. Okay, this is the general formula. Either you take this one or this one or this one. Okay, this is the general formula. IAA is equal to IC plus AD square. Okay, you have to use this one. See, IAA is equal to IC plus AD square. Okay, what is this IA, ICC, IA plus AD square? What is this? I will tell you clearly. You see here, it is nothing but it's very simple. The moment of inertia you have to find out in x direction and you have to find out the y direction. Okay, so in this here both the term, the common is IC is a common. You have to use general formula. Moment of inertia for a rectangular section is BD cube divided by 12. Okay, what is this? IC is moment of that is the moment of inertia at the centroid of the one individual section you will take now. So that is BD cube divided by 12. Area is the area of the individual first any section you take, no, that was the area. Distance, what is the d, I will tell you. Okay, so important is d. If you know d, then rest of the things are very simple. Okay, see here, first one I will take. See here, whatever the section is there, I will just expand. Okay, so consider I am finding the x direction, moment of inertia in the x direction. Okay, x axis. See here, the moment of inertia in the x axis I'm finding with reference to x axis. Okay, what you have to do is take this formula. Okay, so IC is the centroidal moment of inertia to centroidal axis. Okay, use the formula BD cube. For a rectangle section, it is BD cube divided by 12. So B is breadth. Okay, so breadth is 200, depth is 10. Okay, so here you see here, this formula is first one. This is the first section, this is the second section, and this is the third section. How many sections are there? You have to keep on adding. Okay, first section, second section, third section. For the every section you have to use this formula. Okay, for the first section you have to use first formula, plus second section is there, again you put plus and use the same formula and do it again. Third section is there, again use the same formula and find out the moment of inertia for third section. Okay, then all together you have to add it, that's all. Okay, see here, IC refers for BD cube divided by 12, centroidal axis for centroid for the moment of inertia through the centroidal axis. Okay, passing through the centroidal axis. So that is nothing but BD cube divided by IC is BD cube divided by 12, B is 300, D is 10. Okay, so 300 into 10 cube divided by 12. So BD cube divided IC is over. Okay, next is area. What is the area of the first section? That is 300. This is 50 plus 50. So 300 into 10. So area. This is area. Okay, this is BD cube divided by 12. Okay, so this is area. What is this 135.625? So that is nothing but, consider you have taken the section 1, centroid will exist at here, so exactly at 5. Okay, got it, exactly at 5. You have to remember this one. See, you have to focus it. Okay, very clearly you have to focus it. See here, see here, the height from here to here, it is 140.625. But what is from here to here? Okay, you know that from here to here, from here to here it is 5. Okay, so total height is 140.625. So what you do is you just minus it, 140, just minus it. What is that? 140.625 minus 5. So if you minus that, what you will get it? Just minus it. Okay, so see here, what I will do it, 140.625 minus 5. Okay, so that is 135.625. so here d square is there, no, d, in the place of d square you have to write that distance. What is that? 135.625. see here, 135.625. so that is nothing but, see, every individual section you take it. For every individual section, see here, first section is there. From the first section, centroid of the first section to this centroidal of this total section. What is this line? What this is, the line is the centroidal line. That is what you have been determined. Okay, this is what the centroidal, this line is centroidal of the whole section. Okay, but if you take first section, section 1, in the section 1 the centroidal will exist at the 5 mm from the total depth. Here from here to here depth is 10, but centroid of this section you will get it as 5. From the base 5 mm you will get the centroid. So every individual section you take it, from every individual centroid to centroidal of the big the original section. So that is the D. So this is the D. Okay. So I will show it in the very clean figure. Just to see here. So what you have to do, you have to find out the y now. So y, how to find out from this whole section. So here you already know that how to take the I value and A value. Only you have been problem in this D. Okay. So what you have to do is how to find out the D of individual section to the reference axis. What, how to do, how you got this 135.625 I told, but I will tell you in the with a clear example. Okay, see here, general what you have to do is, see here, every individual section, so the total section is there. So consider this is the centroidal axis, what you got 145 point something you got now here, 140 here, whatever we got centroidal axis, that here centroidal axis we got it now. So that one is a centroidal axis for the section. Okay, so for the total section you take this. Okay, see here the total section, this is the first section, though this is the centroidal axis. So if you take this is the first bottom section, section 1, the centroidal will exist at here. Okay, what is D is the centroid of section 1, centroid of the, consider this is the centroid of this section. So what is this line is centroidal of whole section, which you have determined, that is y bar. What you have did be determined, that is y bar, this one. Okay, so y bar from here to here is a y bar distance. Okay, clear? This from here to here distance is y bar. Okay, so the distance of centroid of individual section to centroidal distance. Okay, so this is D1. Okay, got it? So same way, see here, from here, so from here to here the length is 300. Okay, length is 300, centroid will exist exactly at 150. So here to here it is length is 300, but here length is the centroid will exist at 150. But what is this length? Here reference axis, here it is centroidal, from the base to here centroidal distance is, that is y bar is 140.625. okay, this is y bar. Okay, year to year you know, but year to year what is the distance? So the D is nothing but centroid of every whatever the section you take from there to here. Either your centroid lies above the centroidal axis of this one or below the centroidal axis of this one. The distance what you take, that is D. Okay, earlier see here in this one D, the centroid lies at here below the centroidal axis. So this is the centroidal axis, common one. Okay, so which like this, just I separated the section, that's all. Okay, centroidal axis which is common. Okay, one here for the first section, centroid will exist here. For the second section it lies above the centroidal axis. For the third section it lies here, the centroid will lies at here. Okay, for everyone where the centroidal axis you will get it, that one you have to determine. See here, like this you have to determine. So this is D1, this is D2, and this is D3. Okay, so like this, see here second section, for the centroid of the second section will be lies exactly at 150 from here. Okay, 150 from here. Okay, so third section also it will lies exactly at here. Okay, so centroid of the third section to the centroidal distance you need to determine. That's all, very clear. Okay, same way I will go here. Okay, see here 140.625 is there, the centroidal will exist 5 mm from the base. So 10 divided by 2 is 5 mm. So here you will get it 5 mm. So 140 minus 5, that is 35.625. You will get it. You minus it, you will get it. Okay. So here the from here to here the depth is 300. 300 divided by 2 is 150. Okay. So here the centroid will get exactly at here. Okay, centroid of the second section, here it is. From here you have to see very carefully. 300 divided by 2 is 150. Okay, so from here it is 150. Okay, but from here to here it is 10. So totally from here to centroid of the second section is totally it is 160, which I'm writing here, that is 160. Okay, but centroid will be centroid of the whole section, the centroid of the whole section which is been drawn in the textbook, that is 140.625. 160 minus 140.625, it is 19.375. You minus it, 160 minus 140.625, you minus it, you will get 19.375. So that's what in the second section it has been written, 19.375. okay, 19.375. Next see here, I will rub it, so otherwise you will get confused. Okay, so third section is this one, third section. So depth is 10. So 10 divided by 5, 10 divided by 2 is 5. That will lies exactly here. Okay, so from here, from here, exactly from here to bottom, what is the height? See here, from here to here it is 10, from here to it is 300. 10 plus 300 plus 5, so totally it will be totally to